All right, so you guys ready to get started on number 5? Number 5, we're going to talk more about distribution, but we're also going to throw in some probability. We're going to talk about distribution and probability using a bell-shaped curve. We're going to talk about normal distribution mostly, and then we're going to come back and talk about some distributions that are not quite so normal. Well, what is normal distribution? Let's get a quick look at that. Normal distribution. A lot of you have seen a bell-shaped curve. You might not know exactly what the curve means or what we do with it, so we are going to find out in this particular problem. But we're going to talk about this curve a lot throughout the entire semester. I'm just going to introduce you to it today. So when we talk about our bell-shaped curve, we have a set of data. Let's just go back up to our Army recruits. Our Army recruits here had a mean of 72. So if you think about that 72 being right here at our mean, 72, my standard deviation for the Army recruits was 4. So that means that the first standard deviation to the right would be 72 plus 4. So this number would be 76. The first standard deviation to the left would be 72 minus 4, so this would be 68. So our standard deviations, the first standard deviation is 68 inches to 76 inches. So that means that of our set of data, it is highly likely that if you add these together, you get 68.2, that at least 68.2% of our Army recruits are between 68 inches and 76 inches tall. That's what a standard deviation is. And if you just look at the set of data, you can see that, yes, most of them fall between those numbers. Let's just look real quick at our mall shoppers. If I was going to do this same thing on the mall shopper, let's just say that this is 59. Can we actually just call it 60 for the sake of the math and the higher standard deviation? So let's just say that our mean here is 60, which means our first standard deviation to the right will be what? 74. And our first standard deviation to the left is going to be, what is that going to be? 46. So that means that 68.2% of the mall shoppers are between, what did I say, 46 inches and 74 inches tall. Those are how standard deviations work. And we're going to actually do some standard deviations with some different data, which I'm excited about. So let's just go ahead and get started with this. So we have a lot to talk about, a lot to do, and don't forget, I'm just introducing you guys to these topics. We're going to do a lot more with them as the semester goes on. So the first thing I'm going to write up here that I'm dealing with sleep patterns of 217 Duke University scholars. All right, just going to select that cell, make it bold. And now, what kind of information am I given? Well, I gave you a link to click on here where you can go get all this data, or you can just use, I also just cut and pasted in here to keep it a little simpler. So I have 217 students, and what do I need to make a bell-shaped curve? Well, believe it or not, for all of this stuff, I could actually do it with nothing more than a mean and a standard deviation. So let me show you how that works. It says here that the mean hours of sleep. Let's see, sleep patterns. I better change this to sleep number of hours. I don't know, number of hours. You guys can do something more clever with that, but I do need to know what I'm dealing with here when I say mean and standard deviation. So the mean hours of sleep were what? 6.7? And the standard deviation, just going to abbreviate standard deviation, here was, what was it, 2.03. All right, so now I have this nice little chart, and you know what I'm going to do. I'm going to put some borders around it, make my mean and standard deviation a nice little color, and my data a different color. All right, now I'm ready to have some fun. Remember when we looked at the normal distribution, we saw these standard deviations marked down here. We're going to go ahead and create a little chart like that, just like right down here. Let's just select how many do we need. We're going to go to 4. You see here they only go to 3 standard deviations. We're going to actually go to 4 standard deviations for the sake of our curve working in Excel. So I am going to select, what was that going to be, 9? So 1, 2, I'm going to actually start over here. 1, 2, 3, 4, 5, 6, 7, 8, 9 cells. I'm going to paint them so I do not lose where they are. And I'm also going to border them. All right, now in these cells, I want to mark some stuff. First, I want my mean. So in the center cell, I am going to insert what we call a mu symbol. My mu symbol is already right here. So I can just insert it. You are going to have to look for it. It is a Greek letter, so you can normally find it. If you cannot find it, what should I do? Same thing I did before. I do actually get quite a few complaints about not being able to find some of these symbols. So let's just go ahead and stick it in here real quick while I remember. And I'll put the standard deviation one in there too. All right, so we have our mu that signifies our mean. I'm actually going to select all of these. I'm going to go back to home and center it, make it bold, and that should be good. Well, let's see, I'll even raise the font just a little here. Okay, so now I have my first standard deviation. I'm also going to go back to insert, and I'm going to insert a symbol, and it's going to be my sigma. This is a lowercase sigma, also found in the Greek letters. So I will go ahead and put that for you also into the Word document. So when I actually resave this, these will be here for you guys. So back to what we were doing. You guys have your symbols there. Now, I'm going to just copy that and put it in all of these cells because I'm going to need it in all of them, so I may as well just do it now. This is going, how is this notated on my bell-shaped curve? The 1 goes first and then the sigma. So I'm going to put 1. And then on this side, I'm going to have -1. All right, Excel does not like that I put that negative sign there. It thinks I want to do something. So anytime this happens, and it does happen, all I have to do is put a little apostrophe, an apostrophe, and hit enter, and now it knows I'm not trying to do anything special. So apostrophe means, no, I'm not trying to do anything special. So I'm going to have to put an apostrophe every time I use a negative sign. And believe me, it takes a long time to Google all that stuff when you don't know it, so be happy. All right, so now I have my 4th standard deviation. All right, cool. Now let's see what we're going to do. Right here above my mean, I am just going to put an equal sign and click my mean right up here. I am also going to select this entire row here. I am going to go back to home. I'm going to center it, make it bold, give it some borders, and increase the font size. It's because it looks good. That's the only reason. And then I will even give it its own color. Should I just make it the same color? That'll be fine, won't it? All right, now I'm going to do some other fancy stuff with these colors later, you'll see. Now I know that this next cell is going to be my standard deviation plus 1. I'm sorry, my mean plus 1 standard deviation, my mean plus 2 standard deviations. So let's see how we can make that happen. I'm going to press the equal sign. And then I want to do my mean, so I can just use this cell here. Now, I want my mean to stay the same no matter what I do to all these other cells. So just to save myself from typing this in a bunch of times, I'm just going to lock this in here. Okay, and then I am going to add 1 standard deviation, which is right here. All right, you guys see how I did that? All right, so there's my mean, and now there's my mean plus 1 standard deviation. Now I'm just going to drag this all the way. Actually, I just thought of something else. I'm going to also lock in my standard deviation. I just thought of something to make this easier than how I was actually about to do it. All right, so now I've locked in my mean and my standard deviation. So I'm just going to drag this all the way over here. I'm also going to copy it and put it all over here. So there, this is going to make everything so much easier, yay. So now my first standard deviation is fine, but my second standard deviation has to be 2 of these things. So 2 times my standard deviation. Do you see how I just added that in there? And then the next one is what? 3 times my standard deviation. And then the next one is the mean plus 4 times my standard deviation. All right, now over here, I'm going to change this to a minus. My next one is going to be minus 2 times the standard deviation, minus 3 times the standard deviation, and minus 4 times the standard deviation. Whoops, what have I done here? Something wrong. All right, and I know this is a negative number, and that's okay. We only went out this far to be able to draw our curve, and you'll see how it's going to look. I know we don't get negative hours of sleep. That doesn't even make sense. But for the sake of the graph, we're going to go ahead and go out to that 4th standard deviation. All right, now some fun stuff is about to happen. I am going to make a big, long list. Starting with our lowest value here, negative 1.42, I'm actually going to create a list. So I'm just going to start my list right up here. I chose 1.42. I can't really make this bigger because then I can't get everything into the screen, so I'm sorry about that. Here I have, I guess I can do this, can't I? Yes, I know you're thinking, well, why didn't she do that a long time ago? Sorry. So now I have my negative 1.42, and I got that value right from over here. And now what I'm going to do is create a list that goes from negative 1.42 all the way to 14.82. And I'm just going to count by, I just chose negative 1, so now it's going to, all of these values are going to be raised by 0.58. So I am going to simply select these 2 cells. So 1 click, and then drag it down, and now get my little black cursor, and I'm going to drag it down. You see the numbers changing to the right where my cursor is? I'm just going to go kind of fast now. I'm going to drag all that down, all the way down to 15. All right, so a little over 15 is not going to hurt anything. I'd rather you go a little over than under. So now it just filled all those numbers in. I'm going to make this, I guess I'll leave it big because the next thing we're going to do is I'm going to put in an equal sign, and we're going to type normal, because I'm going to try to make this into a normal distribution. So we are going to use right here where it says normal distribution, and it asks us for some information. It wants the x value. Well, the x value is going to be the number to the left of this. So in this case, it's negative 1.42, comma. I want my mean. My mean is right over here. I'm just going to click in it. Don't type it in, guys, because we're going to change this data. And once we change it, all this is going to have to change with it. So now we have our mean, comma, standard deviation, comma, and then for our cumulative, we're always just going to use false. Anytime we use it in this class, we're going to use false. All right, close my parenthesis and hit enter. Now, what this has done is it is creating basically random numbers that are going to be within a normal distribution according to these numbers to the left. So it's actually a pretty cool thing. I'm going to make my picture small again, and now I have options. You can grab this corner and you can drag it all the way down. You can click and drag, or something I just recently learned that a scholar taught me last semester is just set your mouse on there and double click. And you see all this disaster? Guess why it didn't work? Guess why this one worked? This is going to be funny. When I click on this, it's because it came from a value that actually exists. What happened here is that all of these are selecting, you see my mean and my standard deviation? I wanted it to collect the value to the left, but I did not want my mean and my standard deviation to change. So I am going to Control Zulu that mess and come back up to my formula and put dollar signs around the column identifier, the letter, put dollar signs around each of those letters to lock my cells. So the first value was X. I do want that to change. That's okay. But my mean, I'm going to put a dollar sign. Why a dollar sign? I don't know. Probably because whenever they decided they needed this function, the dollar sign was the next thing that was left. We actually use it a lot, so it's nice that I can do shift dollar sign all with one hand and still use my mouse. So it's also convenient. Who knows why they chose the dollar sign. All right, so now those are locked in, and I can just double click, and now I'm going to get some real values. All right, cool. Now I am going to select those values. And well, there are other ways to select the values. Sometimes it doesn't work, so I actually decided not to show you that. When things don't work, it gets kind of rough. I am going to insert a scatter plot with smooth lines. What about that? A scatter plot with smooth lines. Isn't that cool? And now I have my very own bell-shaped curve. I'm going to go ahead and select all of this stuff that I have down here and just pull it down. All right, I'm also going to kind of drag my graph around, see if I could possibly get it like on the right spot, but usually you can't get it right on the right spot. And now I can see I have my mean here. Well, actually, I'm going to actually do another piece of this that I want you guys to do. I am going to insert an illustration, a shape, and it's going to be a rectangle. And I'm just going to make a rectangle here. So now I want my rectangle. I don't want it this dark. I want to be able to see through it. So I'm going to right-click, Format. I'm going to go to, you see right here, mine came right up. So click on your paint can, and when it goes to fill, you can click on transparency. And we can even put no line and then make the fill. Isn't that cool? All right. So now I'm going to show you my first standard deviation. So my standard deviation here was 2. That means that's going to be at about 22. Doesn't that look like about right? 22 there. Should I make this bigger? All right. Now I'm going to copy that. Move it over here. And what's my next standard deviation? Goes, oh, we don't have good numbers down here. Let me just pause the video real quick and see how to fix this because I do not know. All right, you gotta love Google. This is very exciting to get to learn this too, which I didn't realize. I am going to delete this curve. You can delete yours too. And you can see how this curve was made only from this set of data. I do have to actually use both sets of data. And I learned how to do all this from watching Mr. Excel. So that was pretty cool. All right, now insert a smooth line. There we go. Now it makes more sense. And I'm going to go ahead and bring this shape, my graph, I'm going to right-click it and send it to the back. Can I do that with the graph? No, but can I do it with my shape? So I'm just going to click my shapes here, both of them, and send them to the front so they're not behind my curve. Now that I added my curve after, then the shapes got behind it. All right, let's have a look at what we have going here. This makes way more sense. So now let's stretch this out. We have about 6.7. I'm going to say is probably right about there. What do you guys think? And you're not going to be able to get it exact. It's okay. But what I do want to see look pretty good is where these colored bars end up. So we know that we have, I'm actually going to spread that out a little more. I changed my mind on something about these bars. I'm going to select one, hold Control on my keyboard and select the other. And I decided that I do want them to be outlined. So I'm just going to outline them in a darker blue. And that's just so that I can really see where they end and begin. So I think that's about right at 6.7. I'll say that's my mean. And then remember, what did we say this was? 34 0.1%. Let's put that in the middle of this thing. Let's change the font on that. All right, so I just changed that to black, and I can even make it bold so that you can see it better. So this is supposed to go from 6.7 to about 4.6. So I think this needs to be wider till it looks like it's less than 5, because 5 is going to be right in the middle, so 4.6 will be right about there. All right, I'm just going to delete this and copy this one. All right, look at there. Now I know that between 4.6 and 8.73 hours, that 68.2% of the students have patterns of sleeping that many hours per night. All right, what's next? Let's see. Control. I guess what I really could do here, just copy one of these. That's all I need to do. And I already did. So here's a copy of this. I'm just going to change the color, the fill color. I can just go to this paint can up here and just change it to a different color. We'll make it peach. Since I already have it transparent, then I can just choose a little bit darker color. All right, and then what was the next standard deviation? What percent was that? Let's go back and look at our normal distribution curve, and it was 13.6. So I'm going to change this to 13.6%. And I'm going to copy it. Let's see, Control Charlie, Control Victor. I think I copied it on top of itself. We've already seen that happen a couple times. All right, so there's that one, and there's on that side. So there's my second standard deviation. So now I know that if I add all this together, what did all this, remember we had some graphs that told us? All of these added together, everything under this curve is about 95% of our data. And we just find that by adding all this up. What if I wanted to know about what percent of students sleep between 6.7 and 4.6? Well, just 34%. But if I said how many students sleep between about 2.5 hours to about 11 hours, I could say, well, about 95% of them get between 2.5 and 11 hours of sleep, approximately. All right, and we can keep going building these little things. I'll just change the color of this again to be green. And then I'm going to change the percentage to be, what did we say this one was? 2.1. Copy and paste. All right. So now you guys can see exactly what a standard deviation looks like. The average difference between the number of hours of sleep these students sleep is 2.03 hours. So that's what our standard deviation looks like. Now, there's another piece to this assignment where I want you guys to kind of mess around a little bit with your standard deviation. So let's see what that's going to look like. If I changed my standard deviation here, remember how I had you connect everything? That was for a reason. Let's say the average distance, the average difference between their sleep patterns was half an hour, 0.5. Look how skinny our graph gets. All of our percentages that we just so tediously created are not correct anymore, but I can just move them over there and move them back later. So look how my standard deviation is so narrow. What if the average number of sleep between these guys was actually 4 hours? What would it look like? A very wide curve. So depending on the standard deviation changes how wide our curve is. So I'm actually going to undo this and get us back to normal. So now I want to know, where do I fit in this normal distribution of sleep? So I'm going to insert a line just to help me keep track of what I'm doing here. So my line, actually to keep things simple, I can just copy one of these things and make it, just delete the numbers from in there, make it really, really thin, and I can just fill it up with dark color, which will be black. All right, so now I have a line here. And my line, oh, it's because it's on transparent. That's why it didn't come out as dark as I had hoped. So I'm just going to format it, take it off transparency here, which is actually over here. All right. And then let's also just give ourselves a solid black line. Probably would have been easier to just insert a line after all that. All right, so I want to see where I fit in. I usually sleep about 6.5 hours. So I actually fall just below the mean, very close to the mean, but just below it, because I'm usually about 6.5, between 6 and 6.5 hours. So I'm just somewhere right over here. Now, if I wanted to know what percent of people got about as much sleep as me, got as much sleep as me or more, well, that would be real easy to figure out if my sleep was 6.7, because then I could just calculate these probabilities, add them up and calculate about what percentage of people sleep more than me. But because my average number of sleep does not fall directly on first, second, third standard deviation, it's somewhere in between, I have to use what's called a z-score to figure out percentages for relative to my own information. And we're going to look a lot more at z-scores as this class goes on, but right now for this, when you write your report, I would like you to just talk a little bit about your z-score, where you fit in here, and between which standard deviation. So I fit between the first standard deviation and the mean on the left-hand side. So talk to us about how you fit in, and we'll look at our z-scores for other stuff and actually use a z-score chart. You guys want to see what it looks like real quick? Let's just have a quick look. It's actually really neat the way it works and helps us with probabilities. I can't wait to do our bigger probability projects. Z-score chart. The z-score chart, like we just described, that my z-score was less than 1. And we actually have a formula to calculate z-scores, and we'll look at all that later, but this is what a z-score chart looks like. I'm not even going to begin showing you how to use it right now, because we'll do all that later on in the semester. Okay, awesome. Now, the last thing we're going to talk about here is what happens when the distribution is not normal. Well, we know that if our mean and our median are about the same, that we will end up with a normal distribution. Sometimes, we're going to go to this link here, and it says to transcribe the first graph you see. That's this, and transcribe just means to get your snipping tool and copy this graph in here. Now, this particular graph is distribution of household incomes in America. So this is about 50,000 here. This is our median. So if we put all of the household incomes in order and we took out the center value, it would be right at about 50,000. But the mean, does this give us the mean? I don't think this one gave us the mean, but the mean of this data is somewhere over to the right. And we know that because of the way that it's skewed. We say that this data is skewed right. And the reason that happens is because we have a couple of outliers, what appear to be outliers over here. We have a couple of folks making, well, this bar, if you go on to read this bar right here says that it's actually higher than all of these incomes. So we have a lot of people who are making over 250 grand a year. So our median is all the way over here on the left, but our mean is farther to the right. So it makes a tail drag out on our data, and we don't get our nice normal bell-shaped curve. So we're going to talk about the reason why this data cannot be normally distributed is because we have too many values that do not fall within the normal range. We have these extreme outliers that make our means and our mean very different. All right, so we see that this cannot give us a normal distribution because we have some outliers here that are skewing the data, dragging. If the mean and the median were the same, it would be a nice curve, but this has just dragged the data right over here and gave it a tail, so it is skewed to the right. All right, and that's what you're going to talk about in your report. You guys should have no problems writing up a nice little report here, so don't forget your report. I will remind you that you are going to insert a text box here and discuss everything that we did. So we're ready now for number 6.